All right, so 10.4, hyperbolas, very similar standard form formula to what we were just looking at on 10.3 with ellipses. Okay? An ellipse, the distance between your foci and any point was always the same. And now with a hyperbola, the difference of the distances between the foci and a point is a fixed constant, d2 minus d1. So it's the difference versus the sum, okay? In terms of visually looking at the equation and saying, well, how do I know? It's subtraction. Subtraction between the two terms is what tells us hyperbola versus addition was the ellipse. Otherwise, they appear the same way. Graphically, hyperbolas to me look like two parabolas where the vertices are on the insides, so they can either be horizontal or vertical. And you have what's called a transverse axis here. If your x squared term comes first, your transverse axis is horizontal. If your y squared term comes first, and the first is significant because the second would be negative. So even if it was written in the reverse order, you would want to put it so that it's blank squared minus the other term squared. Okay? So if the y squared comes first, then the transverse is vertical. So HK is your center, right? Similar to what we did before. The vertices are A units from the center. A will be the first term's denominator, well, the square root of the first term's denominator. Okay? So it could be under the 8x, it could be under the y, but that's how far apart the vertices are from the center. The foci are C units from the center. Okay? C is not a value that you can extract from the standard form. C is a value that we need to find. It's proven in the book. We're not going to take the time right now to do it. It is a little bit different from the ellipse. Now C squared is equal to A squared plus B squared. Okay? Again, it all stems from triangles and how we're connecting these distances, etc. Okay, so those are the key things from this page. Other key things. A is not necessarily larger than B, right? So with the ellipses that matter, here it's just a matter of what the first term's denominator is. That's your A, okay? Right? Because in an ellipse, it was all about do I run horizontally a larger value than I run vertically, and that's what made us more of a stretched out horizontal ellipse versus the other way. So it really did matter there. If y squared is subtracted, then the trans is horizontal. I was saying it to the other way. If x squared comes first, then it's horizontal. The second way, if x squared is subtracted, then it's vertical. Or if y squared comes first, it is vertical. For sketching, take the root of the denominator and mark that distance from center in the direction of the numerator's variable to make the rectangle. Okay, so you figure out your center, your h comma k. If x squared is coming first, right, you take the square root of what's underneath of x squared term, and you move left or right that many units. Then you look at your second term. If the second term happens to be y squared, you take the square root of that and move up or down in that many directions, and that makes your rectangle. Okay. Equations for the asymptotes of these hyperbolas. If your transverse is horizontal, then your asymptote is going to be k. Asymptotes, I'm sure the plural, they're basically going to form an x between the hyperbolas. Okay? So it's k plus or minus b over a, x minus h, or k plus or minus a over b, x minus h, horizontal versus vertical. trying to think of a way to help us memorize the difference, because it's very subtle, right? B over A minus over A over B, where A is always the denominator of the first term. So if this is horizontal, that means that it's an x squared. Minus the y squared. And this one is the y squared minus the x squared. I'm not seeing a great way to remember B divided by A versus A divided by B. So it's just a matter of what recalling that information. All right, so our first two examples. Make some room. Oops. For focusing on the one on the left first. And then I should be able to zoom out and do the one on the right. Okay, so find the standard form of the equation of a hyperbola with foci at 0, 0, and 8, 0, and vertices at 3, 0, and 5, 0. So we need to find all those key players. We need to figure out the center. Then we can say, oh, our vertices are this far apart. That's our A. Our foci are this far apart. That's our C. And come up with all of those values. And then finally, we can come up with our B. So the first thing I would say here is, what's the center? Right? The center would be in between the vertices, or also in between the foci. Right? It doesn't make a difference. So for the center between the vertices, from 3 to 5, halfway through is 4. So we're going to have 4, 0. By definition, your vertices and your center are A units apart. Right? So to go from the 4, which is your H, to your vertice, which is H plus A, plus or minus A, comma K, that means that our A is 1. Okay with that? Our foci, which we see there are 0, 0, and 8, 0, are going to be H plus or minus C, comma K. So our C is 4. Okay. What I can kind of visualize, right, continuing to wrap my head around this, if I have my center and I see that my vertices and my foci are heading off in horizontal directions, then I know my transverse is horizontal. That's just what I'm kind of visualizing. I could start sketching or whatever. So that tells me, okay, my x term comes first, x minus h. So x minus 4 squared minus, by definition, y minus 0 squared. So I'm just starting to put together my standard form. I need my a squared. I need my b squared. Well, I have my a, so I could even fill that in. The last piece of information for my standard form is I need my b. So if I have an a and a c, I can find my b. So a squared plus b squared equals c squared. So b squared would be equal to a squared minus, nope, that's not right. C squared minus a squared is what I meant to write. So b equals the square root of 16 minus 1, or root 15. So you can write it in the denominator as root 15 squared. Or, of course, if we were to take what we just came up with here and simplify it a little bit, yeah, x minus 4 squared, keep the 1, drop the 1, who cares, minus y squared over 15, all equals 1. Okay? So you start with the information that's given, obviously, and then you start pulling together everything else. The vertices are A units away from the center. The foci are C units away from the center. All right, so from there, we can plot. We can plot our center. 1, 2, 3, 4. We can plot our vertices, 3 and 5. We can plot our foci. Right there. And then that whole rectangle idea, right? So I already went left and right A units. Now I can go up and down B units, which B is square root of 15. It's almost 4, right? If I just wanted to get a rough idea, it's almost 4. So that's the rectangle that we would be referring to. Why is that rectangle helpful? That also helps us figure out the asymptotes, which we're going to do in the next example. So hold tight, or maybe in 2 examples, I forget. Hold tight. But for now, rough sketch of the rest of the hyperbola without our asymptotes in there would be like that. That was pretty good, right? Yeah. Not always am I that good, but that looked pretty good. Questions on that first example? Okay, so here's our second example. Sketch 4y squared minus 9x squared equals 36. So here's our end game. We're going to get there. How do we get there? Well, one observation. Y squared comes first. So this is going to be a vertical one. Okay? But we've got to put it into standard form so that we can extract key information. So it's great because I only have 2 terms on the left. I don't have to complete the square. Right? I don't have that bx or by term there. I can start by just finding my 1. Right? It has to be equal to 1, so I divide by 36. So then I have y squared over 9 minus x squared over 4 equals 1. All right, I like to write it as y squared over 3 squared minus x squared over 2 squared equals 1. Okay, so key points. So our center is at h comma k, which is 0, 0. Now, we are vertical. We are going to be adding our a to the k value since we're vertical. So it's h comma k plus or minus a. And our foci will be h comma k plus or minus c, which we don't have yet. Right? So our vertices end up being 0, 3 and 0, negative 3. We can figure out our c because we know our a and our b. So we would say 3 squared plus 2 squared equals c squared. So c is going to equal square root of 13. So we have 0, square root 13 and 0, negative square root 13. So center 0, 0. Vertices at 3 and negative 3 on the y-axis. Foci root 13, I don't know, it's somewhere between 3 and 4, right? So I'm just going to put a small dot there. It's hard to see it, right? If we were to go left and right to get that rectangle going on, we would go now left and right 2 units. And you can see the rectangle is really helpful because that is where the asymptotes are going to fall in. Right? And we'll take a look at, well, how do we come up with those equations on our own? But that's where they come in. And the hyperbolas, they're sort of like, well, they are diagonal asymptotes. So they're bounding our hyperbolas, which appear like parabolas, right? No different, in between these slant asymptotes. They're symmetrical. So, I mean, in some senses, it's a very similar idea to a rational function, except for we have two slant asymptotes every time, and there's a lot of symmetry happening. Okay, so now we are sketching this 9x squared minus 4y squared plus 8y minus 40 is equal to 0, and we also want to find the equations of the asymptotes. Okay, so side work before we get into the sketch. I need to get this into standard form, and I'm going to have to complete the square. So it's important and helpful not to divide by the constant until you have completed the square. So I am going to move the 40 out of there. And the 9x squared obviously is a non-issue. But when I first started looking at this problem, I divided by the 40 right away, and I'm like, oh, 9/40, that's not good. That doesn't help me. So I said, well, let me try it the other way and then see what goes on, which did help me. So 9x squared, I'm going to take out the minus 4, leaves me with a y squared minus 2y equals 40. So I only have one square to complete on this problem. So I would add a 1 inside of the parentheses. And I would subtract a minus 4 on the other side as well. Right? Because when I factored out that minus 4, obviously that is distributive. So on the left, I really have a minus 4 happening. On the right, I also need that minus 4. So now, cleaning it up, I have 9x squared minus 4 times y minus 1 quantity squared equals 36. Great. The 36 is way better than the 40 was. So now I divide through, and I have x squared over 4 minus quantity y minus 1 squared over 9 equals 1. Awesome. So I have a center at 0, 1 this time. I have vertices. This is horizontal, so I'm adding my A, which is a 2. So 2, 1, and negative 2, 1. So far, so good. To get my foci, I've got to come up with my C value, so I need to do that. I have my A and my B, so 2 squared plus 3 squared equals C squared. So C again is root 13. So I have root 13, 1, and negative root 13, 1. And the last piece is I have to come up with that those asymptotes for the horizontal transverse. So when I'm doing asymptotes when it's horizontal, the B is over the A. So my linear equations, y equals k, which is a 1, plus or minus. It's the 1 because it has to shift. That's my y-intercept. That's where my center is. It's going to cut through the center. Plus or minus b over a, so 3 over 2, x minus 0, so just x. So I have y equals 3/2 x plus a 1, and y equals negative 3/2 x plus a 1. So that's all my key information. Right now I want to put it on the graph and have it come together for us. Let me change colors. So starting with my center at 0, 1, I can sketch my rectangle. I'm going right and left 2 units, those are my vertices. Up and down 3 units. They just create my rectangle. But what that does for me, now that we see it come together, is when I put those asymptotes in there, right? My asymptote is 3/2 x plus 1. Starting from my center, rise 3, run 2. Boom, the corner of my rectangle is actually part of my asymptote. So even if I'm like, I don't really memorize this, guess what happens? It comes out when you count your slope. So even if you're like, I don't know what that formula is, but I've got my rectangle. All right, well, based on whether I'm going to have a horizontal or a vertical, it won't matter. I count my slope to the corners of my rectangles, and there it is. All right, and that's my line. So my diagonals, run like that. Last thing is my foci, right? We said it was between a 3 and a 4. The root 13 was right there and there. And there we go.